Now, today we are going to start the discussion about the current electricity, right? Our first session is current electricity, right? So as a free seminar, now we are going to discuss this one. So this is a grade 10 unit, but it has much importance. Therefore, I am going to start your session with current electricity, right? Now, I have attached you a questions tube, and it's in the WhatsApp group, as well as I have sent in the chat as well. Now, you can download it and you can refer it always once I ask you to refer to it, right? Now, I think you all can see me. Okay. Now I'm going to share my screen and right. So this is the questions tube that we are going to discuss today, right? So here this tube is composed of 3 pages and 4 questions covering up all the theory parts you need for your O-level exam, right? So first of all, let's learn some theory parts over here, and then that means I'll be revising you some theory parts quickly, and then let's see how to try these questions, because I know that now you have learned theories a lot, but the thing is, most of you might find some difficulty in answering the questions, right? Don't worry, I'll be sharing this document with you. Therefore, right, you can always find it as an attachment at the end of the class, right? I'll be sharing you the video recording as well. Then you can find it with this one, and let's see what we can do, right? I assume that you will get a good idea about the current electricity today in the session. Let's see. So let's continue. Okay. Can somebody tell me, can you see this empty screen that I have shared? Because I'm going to write it over here. The things that you need will be written over there. If you can't see, then that will be a problem. That's why. Can you all see it? Somebody please respond. Yes, okay. So let's move on to the lesson. Right. Now, if we consider this current electricity, that is a grade 10 lesson. And right, the grade 10, it is your lesson number. Lesson number 19. Yeah, lesson number 19 of your textbook, right? So you might have referred to this one because in the morning I said that we are going to discuss this current electricity, right? So when we are talking about the current electricity, there are 2 types of electricities. That is the static electricity and the current electricity, right? The static electricity, we know that that's the electricity that we find in some non-conducting objects. In the non-conducting objects, that means in the insulators, they can be charged with some static electricity. For example, once we comb our hair will get the comb will get charged, and you will observe that the hair will be attracted towards the comb. Likewise, that is static electricity, right? Then the current electricity is not a thing like that. The current electricity, it flows always. It's a flow of electrons, right? Usually the electrons are flown from the negatively charged terminal to the positively charged terminal, right? So the flow of electron is from the negative to positive, but you have to remember that the current flow is from positive to negative. Always the current flow is from positive to negative. That is the thing that you must remember. All right. Now, to conduct a current, there should be a conductor. Usually, the metals are the conductors that we face. Right. The metals are the metal conductors are there, as well as non-metal conductors too are there, like graphite. But in most of the cases, we find the metal conductors. Then if we consider the properties of a conductor, the main property of a conductor is it has free electrons. Right. If we consider a conducting material, it has free electrons. Now let's assume we have a conducting material like this. Inside this one, there are metal particles. If it is a metal conductor, there are some positively charged particles, and there are free electrons over here, which are dispersed here and there. And once it is connected into an electric supply, these electrons start to flow. This flow of electrons is referred to as a current. So this is the flow of electrons. This flow of electrons is referred to as the current. So that is the basic definition of a current. Right. Now for this, we have to connect this into a battery. Okay, we will have a battery like this. Then that battery is connected to the conducting material like this. So there will be a flow of current. Right. This is the negative terminal, and this is the positive terminal. The negative terminal repels electrons, so the electrons start to move from negative terminal, and it will come through the conductor, and then they will be entered again into the battery through the positive terminal like this. So that is the flow of electrons. The current flows in the other direction, as I have told you earlier. The current flows from positive to negative. Right. So that is how the conductivity takes place. So this green color one is the flow of electrons. Flow of electrons. Right. Now, if we consider the measuring of current, usually we use an ammeter to measure the current. Right. The ammeter is the instrument that we use to measure the current, and to measure the voltage, we use a voltmeter. Right. Ammeter is used to measure the current. And the voltmeter is the instrument that we use to measure the voltage. Then there's another instrument called multimeter. Can anybody tell me what is the usage of a multimeter? All right, I'll tell. The multimeter is used in different ways. That means it can be used to measure the current, voltage, or the resistivity as well. So those are the applications of the multimeter. Right. Now, in a voltmeter, though we refer it to as the voltage, usually we are measuring the potential difference between two terminals, right? that potential difference that exists between the negative terminal and the positive terminal is referred to as the electromotive force. Right. This potential difference is referred to as the electromotive force. Right. So therefore, from the voltmeter, what it represents is the electromotive force. Right. So usually the electromotive force of a cell is equal to the potential difference between the terminals of the cell when an electricity is not drawn from the cell. Right. You have to remember that when an electricity is not drawn from the cell, the electromotive force is equals to the potential difference. That is the thing. Right. Otherwise, if a current is drawing from the cell, then the EMF is not equal to the voltage. Right. Right. Now, there's a relationship between the current flowing through a conductor and the potential difference across the conductor. Okay, so that is when a potential difference is applied across a conductor, the current flows through it. Right. So that means by changing the current, then we can change the potential difference as well. So that is the relationship between the current and the voltage. Right. So this ratio between the voltage and current is referred to as the resistance. Right. So this was this ratio was first observed by a scientist called Ohm, right? A German scientist called Ohm, and with the respect as a respect to his discovery, this law, the law that is giving the relationship between voltage and current is referred to as the Ohm's law. Right. So we refer to as the Ohm's law. Let's see what Ohm's law is. So what Ohm's law says is that the resistance of a certain substance is equals to voltage divided by the current. Okay. V is the voltage, I is the current. Okay. That means what he said is, or what Ohm said is, voltage is directly proportional to the current. So we can remove the proportional mark by adding a proportionality constant, that is the resistance. So the resistance is measured in ohms. The unit for the measuring of the resistance is ohms. Right. The instrument that we use to measure the resistance is called the ohm meter. Right. We call it the ohm meter. Right. Now, by rearranging this equation, Ohm gave the Ohm's law as V equals IR. So that is the equation that you have to remember. Okay. You have to remember that equation. So because we have to apply that equation in almost all the cases where the voltage, resistance, and the current is given. Right. Now this resistance is the reverse force that is given by a particular substance for the electron flow. So it is affected by several factors. Mainly, there are three factors affecting the resistance of a conductor. Right. One is the area of the cross section. Right. The area of the cross section of the resistor or the substance. Then the length of the segment, as well as the material composition of the conductor. Okay. So the resistivity depends on the resistance. Sorry, the resistance depends on three factors. They are the area of cross section of the segment, length of the segment, and the material composition. That means from which the material is made up of. So those are the three factors which affect the resistance of a conductor. You have to remember that. Right. So if we consider the resistors, there are several types of resistors as well. Okay. They are the fixed value resistors, the variable resistors, and the light dependent resistors. Okay. Fixed value resistors, variable resistors, and the light dependent resistors. Those are the three types of resistors that we need to know. Right. Now you know the fixed value resistors. Now we can divide resistors into three. Right. One is the fixed value. Other one is the variable resistors. And the third one is the light dependent resistance. We call them LDR. So the fixed value resistors, you know, usually we use the symbol Okay, so this is the symbol that we usually use to represent the fixed value resistors. That means in the fixed value resistors, we cannot change the resistance. That means if it is 1 kilo ohm, it is exactly 1 kilo ohm. That is, there's a small tolerance level, but if it is mentioned as 1 kilo ohm, it is exactly 1 kilo ohm. Likewise. Then the fixed value resistors are also symbolized like this as well. So their resistance can be found from the resistance color code. Okay, before that, let's see what are variable resistors. Now, variable resistors are symbolized by this. We are drawing an arrow across this. See, those are the variable resistors. Right now, that arrow represents that the resistance can be changed. That means we can change the. That means we can vary the resistance. Then we have LDRs, right? LDRs are the light dependent resistance. Now they change their resistivity, change their resistance with respect to the light intensity. Therefore, they are symbolized like this. Right. So they are being symbolized in this manner. Or we can use the other symbol as well. Okay, it is this. Right. So that is how we represent the LDRs. Okay, let's learn about them one by one later. Right. So if we consider the fixed value resistors, there's a resistors color code. Okay. Usually in the resistors, we have a 4 band. There are 4 bands. So those bands represent different values. Okay. The first band will be the tens place. Then the second band is the ones place. Then the third band is the index of the 10th power. And fourth band is the tolerance level. Right. So it has a tolerance interval. So those are the values. Right. So if we are going to find the resistance of a particular value, Now let's assume you are given a resistor with 4 color bands. Now I'm not going to teach you the resistance color code table, because you can refer it in your textbook even, and I think in your notes also it's given. Usually black is 0, brown is 1, right? Red is 2, orange is 3, likewise it goes on. Then there's gold and silver as well. Gold is -1 and silver is -2, likewise. Okay, so you can always refer to it, and in the exam you will be given that. If you need to find the resistance, you will be given that. Right. Now let's assume you have a resistor. So I'm going to discuss an example. You are given a resistor with a color band of brown, black, and red. Then fourth band may be either gold or silver. It's not very much important for the determination of the value. Right. So as I have told you, the brown color is the number 1, black is 0, and red is 2. Right. So the first band is the tens place, so it is 1. Then the second band is the ones place, it is 0, and third band is raised to the 10th power. So since red is 2, it is 10 to the power 2. So the value will be 1, 0, and 10 to the power 2 means 100. So 1, 0, 100 means the total value will be 1, 0, and another 2 0 ohms. Okay, the resistance can be found like this. Okay, so let's assume you are given another one. You are given another one with, let's say, brown, red, brown, red, and let's say orange. Now the brown is 1, red is 2, orange means 3. So that means this is a 10 to the power 3. So the value will be 1, 2, then 3 zeros. So it is 12,000 ohms, or else we can say it is 12 kilo ohms. Now this is equals to 1 kilo ohms. This is equals to 12 kilo ohms. Likewise, we find the resistance. Okay. Now I told you about the variable resistors. By rotating the adjuster, we can vary the resistance over there. Rheostat is also an example of a variable resistor. Rheostat. Then we have LDRs. So LDRs, they vary their resistance depending on the light intensity. So in the daytime, it has a particular resistance, and in the night time, it has a different resistance. Likewise. Right. Now in the circuits, you have to combine these resistors together. Okay. In the circuits, you have to combine the resistors together. Okay, now one student is asking, sir, do we want to study the table? No, you don't need to learn by heart the table. The thing is, that means you will be given the values. Okay. Right. So let's come back to the lesson now. I'm going to explain a very important part. This is the combination of resistors. Okay. Now the resistors can be combined into different manners, right? That means there are two main ways that we combine resistors. One is the series connection, and the other one is the parallel connection. Okay. Series connection and the parallel connection. Right. So let's learn about those. It's very easy. In the series connection, what we do is in the series connection, we are connecting the resistors in a row. Now we are going to learn the combination of resistors. Under that, we'll be learning two types, series and parallel connection. So first one is the series connection. It's like this. Now let's assume you are given 3 resistors, 3 or any number. You are given resistors. So you are supposed to connect them in a series connection. It's like this. One resistor is there, and the other one is also connected to that. And third one is also connected to that. Now this is a series connection. Okay. Now let's assume it is being connected into a dry cell like this. Okay, so it is connected into a dry cell like this. And we can combine an ammeter and a voltmeter across them to measure the voltage, to measure the current and the voltage. Okay, so if we have connected an ammeter, it will show the current that is flowing through this one. Let's assume the resistances of this one is R1, R2, and R3. And the most important thing here is in the series connection, same current flows. Same current flows through all the resistors because they are connected in the series manner. That means only one wired connection is there. So if a current of capital I is flowing through this one, okay, the same I is flowing through this, through the R2, and I'll use a different color since it is not much clear. If current I is flowing over here, the same I is flowing across each and every resistor like this. All right. Right. So it's flowing like this. So if it is so, we can find out the voltages across each of these resistors. So let's assume the voltage across the R1 will be V1. Across R2 will be V2, and across R3 will be V3. So we can find these voltages one by one. So V1 equals to IR1 according to the Ohm's law. Then V2 will be IR2 according to the Ohm's law. V3 will be IR3 again according to the Ohm's law. Right. We can apply Ohm's law. Right. Then the most important thing here is now in the dry cell the voltage will be V. Right. Voltage will be V, so we can equalize V equals to V1 plus V2 plus V3. Okay, now we know that the total resistance across these will be capital R. If the total resistance is capital R, we can say that the total voltage equals to IR. Then V1 will be IR1, V2 will be IR2, and V3 will be IR3. So I is common in all the cases. Therefore, the equivalence resistance capital R equals to R1 plus R2 plus R3. Okay, R is the equivalence resistance, right? So that is how we find the equivalence resistance in a series connection. Okay. If it is a series connection, we add up all the resistances together. Okay. We can add up all the resistances together. Right. So then let's move on to the parallel connection. Right. Parallel resistance. It's like this. Now, first one is a series connection. Second one is a parallel connection. Okay. In the parallel connection, it's like this. The resistors are connected parallel to each other like this. Let's assume again we have 3 resistors. Then they are being connected like this. And then finally it is connected to the dry cell. Right. So let's assume these resistors are R1, R2, and R3. And there's a voltage of V flowing from the battery. And then the currents will be divided in between each of them. So here the current will be I1. Here a different current I2 because the resistance is different. Here the current will be I3. It is also different because across these resistors there will be different voltages. Different voltages are flowing across these resistors. That's the thing. Right. So here capital I current is drawn from the battery. If it is so, we can equalize capital I equals to I1 plus I2 plus I3. Okay. So we have to find the currents across each of these. Now the most important thing in parallel connection is across all the resistors, the voltage is the same because all the resistors are connected to the same terminals of the battery. Here also the voltage is the same. See, across them we have voltages V, V and V. Okay. Same voltage is there. If it is so, now we know that V equals IR. So I equals to V divided by R, voltage divided by R. So I can be given as V over R. Then I1 is, again voltage is V, the resistance is R1. Then in I2, V over R2. And in I3, V over R3. So V is always equals, therefore 1 over R equals to 1 over R1 plus 1 over R2 plus 1 over R3. Okay. So that is how we find the equivalence resistance in a parallel connection. So for a parallel connection, we can find the equivalence resistance in this manner. Right. So let's see an example. Okay, so let's assume you have connected two resistors like this. And then they are connected into a voltage supply. Like this. So let's assume the voltages of the resistance of this one will be, both are 10 ohms and the battery will be 5 volts. Right. So you are asked to find the equivalence resistance. Now for this we can apply the equation equivalence resistance 1 over R equals to 1 over R1 plus 1 over R2. So it is 1 over R equals R1 is 10. Then the second resistor is also 10. Right. Then we can simplify this one. So 1 over R equals to 10 is the common denominator. 1 plus 1, that is 2. So therefore R will be finally 5 ohms. So that's how we find the resistance in a parallel connection. Right. I think it's clear for you. Right. So that's how we find the equivalent resistance. I think now it is the high time to move on to the tutorial. Right. So in this one, this first question, okay, it's a good question. Actually, this is the past paper question from 2011. Right. This is the 2011 past paper question. Right. So let's see how to find answers for them. Let's find the answers for this question. Okay. Now the question says the diagram shows an electrical circuit constructed to find the value of unknown resistor is indicated. Sorry. Yeah. Are there any doubts, Pudala? All right. So let's move on. The diagram shows an electrical circuit constructed to find the value of unknown resistance is indicated by capital R. Now see here, the capital R is indicating the value of unknown resistance. Then there's a 6 volts battery, see, unknown resistor, 6 volts battery, and a variable resistor is there, that is capital Z, or a rheostat, and a switch, that is capital S. Okay, so those are the instruments that are being used. Name the component capital X. Okay. Now that capital X is connected across the resistor. So that means it is in a parallel connection. Usually we are connecting the voltmeters as a parallel connection with the instrument, with an instrument. Right. Why is that? Because then there won't be any current flowing through that. So the component X has to be component X is the voltmeter. Okay. X is the voltmeter. When the switch was closed, that means when the switch was on, the ammeter reading was 2.5. Now this is ammeter, and X is the voltmeter. Ammeter reading was 2.5 amperes. In order to decrease this reading to 2, what changes in the resistance should be made in the variable resistor Z? Right. Now we know that once the resistance is high, okay, once the resistance is high, the current will be less. The current flow will be less. Once the resistance is low, a higher current will be flowed. So therefore, in order to reduce this 2.5 ampere current to 2 ampere, the change that we have to do in the variable resistance is we have to increase the resistance value. Okay. What change in the resistance should be made? The change is increase the resistance. Right. So once we increase the resistance, then the barrier to the electricity flow will be higher. So then that means a lesser electricity will be flowing. Then third one, when ammeter reading was 2 amperes, the voltmeter reading was 5 volt. Now the current is 2 amperes, voltmeter reading, that means voltage was 5. Name the law you use to find the value of the resistor. Okay, so can anybody give me the answer? What is the law that we are going to use?
Ohm's law.
Ohm's law, yes, good. So we are going to use the Ohm's law. Then find the value of R. So how do you find the value of R? We can apply the Ohm's law, and that is V equals IR. Then we can rearrange this equation. Okay. R equals V divided by I. Okay. Then the voltage was given as 5 and current was given as 2 amperes. So 5 divided by 2 is 2.5. So it is given in ohms. The value will be 2.5 ohms. I think it's clear to you. Right. So then let's move on to the question number 3. Let's keep the 2 aside for a while. Let's move on to this question number 3. Right now, it's a high time for you to try this question. Okay. I'll give you about 5 minutes. Now you have to write the answer for this one. Okay. You can either refer to this question or I have shared the PDF with you, so you can refer to that either. And somehow or other you have to write the answers for this one. Now the time is 8:56. You have time till 9:01. Okay. Quickly write the answer. Okay, your 5 minutes is gone now. Please raise your hand if you need more time. Okay, so nobody has raised the hand. That means everyone has done it. So let's start discussing. All right. So only one student has replied that he has done. Okay, good. Right. So let's answer this one. Right. So below is an image of a setup to find the heating effect of the current electricity. Below is an it is given as 1s, but it's not 1s, it is. Below is an image of a setup to find the heating effect on the current electricity. Okay. Now here you are given a heating setup. 6 volts battery is there. So it is connected to a nichrome coil of 2 ohms resistance. Then there's water stirrer and the thermometer is inserted and a vacuum pump is there. Explain why nichrome is used to make the heating coil. So why nichrome is used to make the heating coil? Can anybody give the answer? Any volunteer? At least in a message.
To give a very large resistance?
Keep a very large resistance. Somewhat accepted. Any different answers?
Its resistance
any
is
different
high.
answers? Sorry?
Its resistance is high.
Resistance is high. Okay. Any different answers? Nobody? Okay. The answer is because it has a very high resistance. Yeah. That is the answer. Right. Answer has to be it has a very high resistance. Then second one. Okay. I'll write the answer also here. You can say nichrome has high resistance. Second one, what is the mechanism by which heat travels through water? Okay. What is the mechanism by which heat travels through water? What is the mechanism? That is the convection, no? Not the conduction. The conduction is for the metals. Convection is for the substances that can flow. So the mechanism by which the heat travels through water is the convection. Right. Then third one, fix into the vacuum pump. Remove air between the air between two vessels. Explain this. Okay. So once the vacuum pump is connected, what happens? Fix into the vacuum pump, remove air between two vessels. Explain this. So once the air is removed, it will cut off the heat loss by the conduction. That means the heat loss by the conduction will be not taken place. So fix into the vacuum pump, remove air between the two vessels. Explain this. So we can explain it as it prevents heat loss by conduction. Right. Then the next one, if the resistance of the coil is 3 ohms and the potential difference is 6 volts, okay, if the resistance of the coil is 3 ohms and the potential difference is 6 volts, what is the current taken by the coil when operating? Okay, now the voltage difference and the resistance is given, so we can apply the Ohm's law, that is V equals IR. So we need to find out the current taken. So I equals V divided by R. So voltage is 6, resistance is 3, so that will be 2 amperes. Answer will be 2 amperes. Then part B, calculate the power of the coil. Actually, this power is being taught under grade 11, but it's been included in this question as well. Okay, the power can be calculated. I'll teach you the equation there. Power equals to voltage into current. P equals VI. That is the equation. So voltage here is 6 and the current is 2. So 6 into 2, it is 12. The unit will be watts. Answer will be 12 watts. Okay. How many of you have got all the answers correct? Please raise your hand. I can see. Okay, good. There are 3 students got all the answers correct. Okay, I'm happy about you. Okay, so you can lower your hands. Okay, I think you haven't done the part B. Okay, so let's try the part B as well. Has anybody tried the part B? Okay, so you can try it quickly. I'll give you another 5 minutes to try answering this. Actually, to answer this part, you need some knowledge regarding electromagnetism. Okay, I think the time is enough. Shall we see the answers? Right. So let's discuss. Okay, now this setup can be used to demonstrate. Now this table, the table below shows some information about the sum of the elements and some of the ions in the periodic table. Of okay, cut off that part. Huh? That means it's a useless part. Okay, this is the question. This setup can be used to demonstrate the function of any of the following devices. Select and write it. So it has to be either a dynamo or motor. Now see here, since an electricity supply is given, this has to be the motor. So it has to be the motor. Okay. That means by supplying electricity, we are making a motion. So that is done in the motor. Then what is the direction of the current flow through X and Y wires? Okay. The current will be flowing from X to Y because this is the positive terminal and this is the negative terminal. And here in X, it will become positive over here and negative over here. So usually electricity flows from positive to negative. So that means it is X to Y. Okay, remember that electricity flows from positive to negative and the electrons flow from negative to positive. Okay, don't miss those two. Electricity flows from positive to negative. Electrons flow from negative to positive. That's the thing that you have to remember. Then third one, write down a physical characteristic of mercury that can be used it in activity. Physical characteristics of mercury. Now here we have mercury. The mercury has the property of conductivity. That's the thing. The physical characteristic of mercury is the electrical conductivity. Okay, that is a characteristic. Then in which direction does the XY wire move from AB letters mentioned on the mercury when the current flows through the setup? Okay, now A is inside the plane and B is outside the plane. Okay, now for this one, now since we have supplied electricity, we have to apply Fleming's left hand rule, not the right hand rule. So here we have to apply the Fleming's left hand rule. So if it is so, now we have the left hand rule like this. Usually thumb represents the direction of motion. This first finger represents the direction of the magnetic field, and the second finger or the middle finger represents the direction of electric field. Okay, motion, magnetic field, and electric field. Okay. Now in this one, the magnetic field is from north to south. So we can keep our middle finger from north to south direction. Sorry, not the middle finger, the first finger from north to south. Then the current is flowing from X to Y, that means it is downwards. So then the motion will be towards you. See, like this. This is the current, this is the magnetic field, and this is the motion of the rod that will be towards us. That means out of the plane, that means from A to B. So in which direction does the XY wire move from A to AB letters mentioned in the mercury, mentioned on the mercury when the current flows through the setup? So it will move towards B. I think it's clear for you. It moves towards B. Then the last question of this one, in the above question, what rule did you use to find the direction of motion of the XY wire? Okay, that is the Fleming's left hand rule. Right. I'll be doing another session regarding this electromagnetism in an upcoming day. Usually, maybe on the next week of the following week, I'll be doing that regarding the electromagnetism. A separate session will be done. Right. So we can apply the Fleming's left hand rule like this. All right. Then the last question, question number 4. Let's answer this. Okay, you have time till 9:25. Answer that part quickly. Okay, I think the time is enough. Shall we discuss? I assume you all have finished writing. Right. So the question number 4, the following circuit diagram is set by a student to check the factors that affect resistance. The A and B gap in the circuit is connected using an equal length, 5 centimeter, and equal diameter copper and nichrome wires separate. And the brightness of the bulb is observed. Okay, now this AB length, it is being connected, one by copper and the other, in the other instance, it's by nichrome. What is the function of A? Okay. So the question is, what is the function of capital A, that is ammeter, that is to measure the current through the circuit? No? Now that A means this one, no? Not this A. So the function of A means ammeter, it is to measure the current in the circuit. Measure the current, let's say flowing in the circuit here. Then second one, brightness of the bulb increases in the circuit in which occasion? The brightness of the bulb increases in the circuit in which occasion? First one, the copper wire connects A and B. Second one, nichrome wire connects A and B. So there's repeatedly A and B is there. Right. So we know that copper has a less resistance than nichrome. Nichrome has a higher resistance. Therefore, a higher current will be flowing once it is connected with copper. So higher the current, higher the brightness. So therefore, A is the answer. In which occasion, that is, once this copper wire connects A and B. That is the instance. This is the case. This is not. Then third one, what is the reason for the above two observation? Because we can say copper is less resistor than nichrome. Copper has less resistivity than nichrome. Okay. Then the fourth one, resistance of the copper wire is 10 ohms and the resistance of the bulb is 5 ohms. Find the electric current passing through the circuit. Okay, so if we connect copper wire over here, it is having 10 ohms. And the bulb is having 5 ohms. Okay, now see, both the resistances are connected in a series connection. Here we have a series connection. If it is a series connection, the total resistance will be 5 plus 10, 15. We can say the equivalence resistance or the total resistance, final resistance. That is 10 plus 5, that is 15 ohms. Then we can apply that to the equation V equals IR. So you have to find the electric current. So I equals V divided by R. Voltage is 3, I guess. Yeah, 3 volts. Resistance is 15. So it is 1 over 5. 1 over 5 means 0.2 amperes is the current that is flowing through this. It is 0.2 amperes. Right. How many of you got all correct? Please raise your hand. Okay, good, great. Okay, so let's see the second question then now. That's the only question remaining that we have to discuss today. Okay. This one, second question. Right, now you can find the answer for this one quickly. I'll give you 5 minutes. So now the time is 9:34. You have time till 9:39. Okay, your given time is up now. Please raise your hand if you need more time, or shall we start discussing? If you need more time, please raise your hand. Okay, so nobody's need more time, right? So let's find the answers for this. So it is stated that the voltage of a motor car battery is 12 volts. This battery comprises 6 electrical cells. Voltage of each is 2 volts. Using circuit symbols, draw how the 6 cells are combined to make the battery. Now the voltage is 12. Right. If it is so, we have to connect each of these 2 volt cells in a series connection to make 12 volt. Because once we connect in series, the values will be added to each other. So we can draw it. It is connected like this. One battery is there. I'll draw it over here. 1, 2, 3, 4, 5, 6. This is how it is connected. That means there are 6 cells. Then use the next second question. The 2 headlamps of the motor car are identical, and the figure indicates how they are connected to battery. Okay. Name how the two lamp bulbs are connected. So they are connected in parallel connection. See, now see these two lamps, they are connected in parallel to each other. Okay. So we can say it's a parallel connection. They are connected in parallel connection. Show in a diagram the other way of connecting the 2 lamp bulbs. Right. So we can connect it in a series connection as well. That means let's assume we have the battery like this. Negative terminal and positive terminal. So it is connected in a series connection like this. So this is the answer. Okay, so that is the other way of connecting the 2 bulbs. What is the advantage of connecting the 2 lamp bulbs as shown in the given figure? Okay. Now see, what if one bulb is blown away? In a series connection, if this bulb is blown away, that means the whole circuit will be incomplete. That means this bulb too will not be working. In the parallel connection, if one bulb is blown away, now the current can be passed through this bulb and then that will be working. Now what if while we are driving in the road, if one bulb is blown away, if we have a series connection, then we will be going fully blind, right? Because the other bulb too will not be working. But if it is in a parallel connection, if one bulb is blown away, the other one will be working. So we can somehow manage to not getting accident. Otherwise, we will face a huge accident, right? So what is the advantage of connecting the 2 lamp bulbs as shown in the given figure? We can say one bulb lights up, even the other bulb is blown off. That is one advantage. Other one is these parallel connection bulbs, they will be lighted with a higher brightness than the series connection. Then there's the reason for that is, since these bulbs are connected in parallel connection, the equivalence resistance becomes lesser. Right? Equivalence resistance will become half of the initial resistance. And here, if it is in a series connection, the equivalence resistance is we are adding those 2 values. Right? So the total equivalence resistance is high. Therefore, the amount of current flowing through the circuit is less in the series connection. in the parallel connection, a higher amount of current is flowing. That means it has a higher brightness. So there are three answers that you can give. One is we can say one bulb lights up even the other is blown off. Then the other one is the bulbs glow with a, that means the bulbs glow brightly. That means they have a brighter light when compared to the series connection. Okay. Then the other one, third one, calculate the equivalence resistance of the two lamp bulbs. Okay. So now, since these two lamp bulbs are connected in parallel, we can use the relationship, that is 1 over R equals 1 over R1 plus 1 over R2. I'll be writing the answer over here. Equivalence resistance equals to 1 over R1 plus 1 over R2. So the resistance of one bulb is 2 ohms, no? See, resistance of each bulb shown here is 2 ohms. So it has to be 1 over 2 plus 1 over 2. So once you simplify, you will get R as 1 ohms. Okay, it is 1 ohms. Then fourth one, find the electric current flowing through one lamp bulb when the circuit is put on the closing key. Find the electric current flowing through one lamp bulb when the circuit is put on closing the key. That means once the bulb is switched on, what is the electricity that is flowing, the electric current that is flowing? We can apply V equals IR. So we have to find out the current. So current equals voltage divided by resistance. Now the voltage is 12 volts. Resistance here we found it as 1 ohms. So there will be, sorry, not 1, 2 ohms, no? One bulb is 2 ohms, no? So it will be 6 amperes. So there will be a current of 6 ampere flowing through the bulb. Then fifth one, calculate the flowing current flowing through the bulb, through the other bulb, if one bulb gets burned. If one bulb gets burned, what will happen? We have the resistance of 2 ohms across the whole entire circuit. So again, current equals to voltage divided by resistance. So the total voltage remains constant with 12 volts, and the resistance will become 2 ohms. That will be 6 ampere. Yeah, 6 ampere will be flowing across the bulb. Otherwise, if there's any instance of increase in the voltage, increase in the current, then that bulb too will be blown off. So it's not working like that because of the parallel connection. Okay. it has a higher, it has a certain resistivity, it has a certain resistance. Due to that, the same current will be flowing through the entire circuit. Okay, that's it. Now here we have discussed. Now I'm going to conclude the lesson today, and here we have discussed several questions, several important questions regarding the current electricity. Actually, these are the structured essay and essay questions, right? So even in MCQs, the same type of questions will be asked, right? Then I need to apologize for today because since my leg has been wounded, so I'm not able to keep standing. So that's why I have used this method of doing the conducting the class, because since I have promised to you, I had to do the class somehow. So from the next week onward, I'm using the whiteboard, and I'm keeping my video on, and we'll be using the whiteboard, and I'll be doing the class as a live class, right? So I think you have got an idea about the current electricity. So can anybody comment on the today's session? Any volunteer? Okay. Okay. Now one girl is saying that she understands well. Okay. Anybody who can speak? If there are several students, can somebody speak? Okay, it's okay. So that's okay. I assume that everybody has understood. I had been having a hard time. So I had been having a hard time learning it. Now it's okay. Okay, happy to hear that. Okay. Okay, I'm happy to hear that if you have understood the lesson. Okay, now you can keep trying these questions, and I must say this. I forgot to say. Now once I teach you a lesson, now there will be about 1 week time for you to revise all these things and engage in the exercises. So whenever you try the questions, you will find some difficult parts. So whenever you find a difficult part, just send me a WhatsApp message. I'll be trying my best to reply at the same instance. If I am not in a class, if I'll be in a class, I'll be replying to you just soon after the class, and that means always I'll be replying you within the same day. So if you find something difficult, send me a WhatsApp message. I'll be helping you. I'll be assisting you. That means you have to do your own now. That means the things that we discuss in the class is not much sufficient for you to write in the exam. That means you have to practice at home as well. So you can have the past paper books, model paper books, and all the things are there. So you have to try your best at home. That means you have to do homework. So I'm not going to specify you some homework because it's a useless thing. That means I cannot specify that you have to try this. Likewise, that is not fair. So you can try your own, and if you find something difficult, I can assist you. That means if you talk to me, I can assist you, right? So I think it was. I assume that it was a useful session for all of you. And now I'm going to conclude this one, and I'll be sending you the recording link as well, because most of the students message me personally that they are not going to join today because they have some other classes. It's okay. So I'll be giving the recording link, but try to connect with us daily and continuously, so that you will get an A pass in the final exam, right? I can guarantee an A pass in the exam if you attend these series continuously, because we will be conducting these sessions 2 days per week until your exam on May. That means we have 2 more months, right? We can conduct another 16 to 20 sessions during these 20 months. So that will be more than enough for you to practice for an A pass for the science. Okay, so since it's late, I'm going to conclude the session today and wish you all a good day and a good night. Okay, see you all next day.